Okay, and we're live. And just checking. I think the lighting is actually not too bad. Just let's just quickly checking on that. Yeah, so sorry for the late start. I was actually doing a quick test run on the whole thing just before the live stream, which didn't really go as planned and triggered a ZFS kernel bug, it looks like. Which then required restarting the system to recover from that. Separately, I also have a slight issue with my home automation stuff, which is currently preventing me from controlling the lighting here. So I'm quickly checking on that server now to see what's up. I'm also seeing a test failure here on our current branch on documentation. Is that just a bad link? That tends to happen. Yeah, link checker, okay. Oops, broken. Okay, I need the actual raw log. Basically just checking if we can retry the thing to make it clear. Okay, Ceph.io is connection timeout. Yeah, so that's probably a temporary failure. So gonna retry that and it should get us back online. Okay, so that's fine. Just quickly checking what's up with that home automation thing. Okay, it's a bit of a weird setup I've got right now, where I've got a server in my rack which runs a container that runs a whole bunch of Docker containers actually for the home automation modems and things. But that server itself doesn't have the all of those USB dongles and stuff connected to it. Instead, I'm going over USB over IP to another machine in a different part of the house that actually has all of the antennas. And I think there's a bit of a kernel issue. I'm seeing pretty wild memory leaks that I need to sort out. And that means that every so often, my home automation system just kind of goes down because of either running out of memory or other kernel issues. I just haven't had much time to deal with that. So whenever that happens, I need to just go and give everything a good kick, restart everything, and then I'm back online. Which I've now just done. So hopefully in the next few seconds or so, I should see my home automation network come back online. And once it does, I should be able to actually control the lighting around here. Anyway, I've got things. Yeah, so camera light maybe 9. Yes, okay, so I just have my front-facing light thing that's working again. Ceiling light is on but hasn't noticed yet, and the lamp behind me hasn't reconnected yet. So anyway, I'll keep an eye on that, might fix it later, but just having the front-facing light will sort most of the issue out. All right. Question about the cat. Actually, he's been complaining quite a lot over the past few minutes, despite being fed and everything. So it's probably he might actually make an appearance. If he does, then I'm gonna show him. Cool. Just going over some of the things in the chat, mostly because YouTube is not always amazing at retaining the chat messages for folks watching things later on. So there were a couple of questions. The first question was around packaging and especially availability for OpenSUSE and some of those other distros. So my answer, and I kind of reiterate that now, was that unlike LXD, with Incus, we're trying to have a pretty clear separation between the upstream project and the downstream packages. So, I mean, with LXD, it was really blurry because the team developing LXD was also the team maintaining the Snap package. And so all of the documentation and everything was kind of Snap-centric, and that was causing a whole bunch of friction and issues. We didn't want a repeat of that with Incus. So there's a bit of a clearer line there where as the upstream project, our responsibility effectively ends at making Git tags and putting out ready starballs, and that's the end of that. And then after that is responsibility of the packages to pick things up and apply it to the different distros. As soon as a distro has packages with solid instructions, we either contribute ourselves or have whoever is doing the packaging contribute the getting started documentation section for the distro, but that's about the end of the involvement there. So that means that I personally, I'm not going to be working on things like OpenSUSE or Red Hat or any of those kind of packages. I'm in a slightly odd situation that since I also run a business that offers support on Incus, kind of separately from my involvement with Incus upstream, then as part of that, I do produce packages for Ubuntu and Debian. I don't personally intend to ever expand past Ubuntu and Debian because that's the only distros I'm familiar with and the only distros I'm willing to commercially support people. So if someone comes directly to me for support on Incus, I'm going to want them to run those packages on those distros. But unlike with LexD, we're extremely open to having a bunch of other companies offering their own services and support, a bunch of distributions offering their own packages with potentially their own support and services, really trying to keep things open there. So OpenSUSE, it's been a bit of a work in progress. It's really ironic because the creator of the Incus project was the LXD packager for OpenSUSE. But he's been quite swamped and not been able to really spend too much time on getting Incus properly into OpenSUSE. That said, there are a couple of folks on the community side that have done it. So if you look, I think if I just Google for Incus OpenSUSE, you'll actually find kind of third-party packages. I think actually linked from that forum thread. I think it's this guy's packages. So you can find packages, they do work. Is there no repositories here maybe? How does that work? Yeah, OpenSUSE, Tumbleweed. Okay, we see packages and that's available for 0.6. So up-to-date packages do exist. They're not in OpenSUSE proper at this point, but there are third-party folks that are maintaining packages that people can consume if they need to. I also keep rechecking Alpine because the packages do exist, but they were in testing last I saw. They're still in testing, okay. So Alpine doesn't have instructions on our side published yet because the packages for Incus in Alpine are not in the community repository yet. It's just in testing, so we're just kind of waiting for that. And the other thing is kind of on the Red Hat side, there's been a development for that last week. If we go look, I think that's the bug. So that's the Bugzilla entry for an official package of Incus in Fedora and in the EPEL repo. And there has been a successful build that got completed on the 29th of February. And it's effectively waiting for review at this point. So if we go look at the build, it actually shows some failures, but for what actually matters, which is Fedora 40 here, we see it did succeed. So I think if we go look at that, yeah, there we go. So you've got the packages again for Incus 0.6. So that's looking pretty good. I don't know how long it takes for the review process on the Fedora side. There's probably gonna be some back and forth, some issues, some things that need fixing, but there's good progress there. And once that clears, that will get not only Incus inside of Fedora proper, instead of having to go through the copper repositories, but will also get Incus into EPEL, which will then cover all of the Red Hat enterprise derivatives. So that's pretty good news there. I think once that covers kind of the Fedora Rel side of things, then it's really pretty much OpenSUSE that's going to be left at that point to get us full coverage of the distros. And I mean, this situation, like it feels like it's a bit weirder than with the Snap because we are dealing with all of those different people doing different things. But at the end of the day, that's really the right way to do it because those folks are experts in packaging for their respective distros. They know how to make it properly integrate, properly feel right. And so it's a much better way to do it, but need to have a pretty tight set of people be up and running doing that. And then make sure that things update every time a new Incus release comes out. There's actually that, what's the name now? Is it Tripology or something like that? Yeah, it is. Which lets you look up package versions across all distros. And we can see, so if we look up Incus, we've got 0.6 that's in Alpine. Some of the Arch Linux builds are behind, they're still on 0.4, but the Intel one's on 0.6, so that's all good. Debian is on 0.6. Homebrew 0.6. So yeah, that gives us a good overview of kind of the state of everything. And that will make it pretty easy kind of down the line to make sure that that things keep up to date, see what distros might need to get like some extra help, or they might be hitting a snag that we can help with upstream effectively. Okay, so that's for that. There was also a question around Ansible, specifically contributing a new, so there's someone working on a new plugin. I think it's around, it's the part of Ansible to actually create instances, create full-on incus objects. So I did contribute the connection plugin, which just lets you run Ansible against any incus VM or container without needing to use SSH or any of that kind of stuff. That's in Ansible proper, that's good. But now there are folks looking at the other two aspects, one of which is that ability to create instances directly, create networks, create those kind of things. So that's being worked on. And the other aspect, I think, is the inventory plugin, which is effectively looking at incus, figuring out all of the instances and turn that into one of the backend inventories for Ansible. So those two are kind of being worked on. And there was a question around, like, should that be done as a separate repo, or how should that be handled? And so long as the Ansible community would be happy to have us, I think the good way is to actually do that directly in the upstream Ansible repos, just like the connection plugin, so that this actually reaches the widest possible set of users. All right, let me just go check if there are any other questions around that. And yeah, I think part of the OpenSUSE question was also kind of related to using the OBS. So that's the build system that OpenSUSE put in place, but that spits out packages for far more than just OpenSUSE. The thing there being that for most distros, when you talk with the distro proper, they don't want that. They want things in their own repo, following their own guidelines, their own review process. So if someone wanted to do something kind of similar to the Snap and just have one package that they develop and then deploys on like all the different distros, then that would be a decent alternative, I think. But what we actually want is to be fully embedded in the distros, working directly with distro maintainers. And when you do that, then OBS doesn't, like the open build system, I think OBS, only effectively becomes interesting just for OpenSUSE because they're the only ones using it for the distro itself. Checking if there was anything else at this point before moving to the actual goal of the stream. As the state of Ansible support. Okay, so that's I'm gonna cover. How about linking to various packages? Yeah, that's done. So if you've not looked at the docs, if we go even straight from the website, when you get to incus, you get the getting started, which gets you here, it gets you how to install incus. And when you do how to install incus, you've got Arch, Debian, Fedora, Gentoo, NixOS, Ubuntu, Void Linux for how to install from packages. There are also source instructions for both Debian, Ubuntu, and Alpine Linux. So that's what we do. Like that page, that installing page does have instructions for all of the different distros. We try to keep that very short so that it's the bits of the instructions that are not likely to change. And then we link to any kind of wiki page or the documentation that might be specific to the distro. So we definitely do that, and we do have that page and we do maintain it. Could you share a link to the Ansible connector I contributed? Okay, so yeah, that was the link about Ansible incus connection. So that was the PR for it, which was merged a little while back. And I think we can also find the documentation for it at this point. So incus Ansible connection. Let's see if Google finds it. Yeah, it does. There you go. So that's the connection plugin, which I quite actively use. Like I do use Ansible to maintain most of my infrastructure, both at home and also for some nonprofits and customers and stuff. So that's been, like, I think I may probably manage hundreds of systems through that connection plugin. That's also why I contributed some things like the keep alive mode, because for me, just running, given my infrastructure uses OpenID Connect, OpenFGA, and all that kind of authentication, just implementing the keep alive mode inside of the incus CLI cut down the full runtime of my Ansible playbooks by like 30%. So yeah, I quite actively use that. I don't know that it's been part. Actually, it does say it's part of 8.4, so it is in a stable release now. Last time I saw it wasn't, but yeah, there's that one, and I said like for LXD there were another 2 plugins, one for inventory, one for creating instances and profiles and the like. So those 2 are kind of being worked on. They're not things that I use myself, so I'm not gonna be like trying to pull them or contribute to them myself, but I've been giving some pointers on the forum, and definitely I'm very happy to help with anything that can be done to improve, like to make it easier to interact with incus. All right. Okay, I think I saw the cat walk in the hallway, so I'm just gonna go pick him up so you can see the cat, and then we're gonna actually get onto looking at, especially looking at Terraform, looking at my incus-deploy repo and kind of what the plans are around that. Okay, I'll be right back. Yeah. Alright, there he is. He was like sunbathing on a chair just outside the room. So that's Arthur. Arthur, that's YouTube. Hi. So for anyone who wanted to see how the cat is doing, it's doing fine. It's just sunbathing on the chair outside. And put him back on his chair. We'll see if he actually ends up sticking there. But yeah. All right. So this this live stream, I really wanted to go over something called incus-deploy, which is kind of a new repo I created a few weeks back. That's not really been worked on all that much, but the idea behind it is to offer both Ansible playbooks and also Terraform kind of definitions and things to show how to deploy incus, especially incus clusters, with things like Ceph and Oven as kind of the more complex things, making that as easy as possible. I'm currently targeting and testing on Ubuntu 22.04. I think that will be expanded to at least cover Ubuntu 20.04, 24.04, and probably Debian 12 or something like that. But for now, just keeping it simple, and that can easily be updated down the line, especially by folks wanting to run it on something else. As I mentioned in another live stream, I think it was in the Q&A one last time around. There's another plan, which is to create like a full kind of incus OS immutable system that can be deployed that would actually avoid running a bunch of those steps. But I think both are quite valuable because we've got folks who do actively want to deploy on their Linux distro of choice and wants to use normal packages and want to kind of have all of that control. And then you've got, at the other side of the spectrum, you've got folks who specifically don't want that. They want something that's got as few moving pieces as possible, that they can just audit, certify, and code it down. So I think both make a lot of sense to do. And currently, given that I've been deploying incus both for myself, for the projects I'm involved with, for customers, using Ansible, I've got a bunch of those playbooks already. They're just kind of too tightly integrated to just copy paste and make public. But I want to do that work to at least get things like Ceph, Oven, and some of the other clustering bits kind of together. I saw another question. Okay, so there's a question about how many nodes can you put in an incus cluster. So our normal answer to that would be 50. In practice, we're quite comfortable going to 100, and we've done some basic investigation going to 200 to 300. On the Raft side, the way it actually works is that they don't all participate. So the way the cluster works on the Raft side is the first tray joining the cluster. Those obviously all become, well, actually, a bit of a caveat there. So Incus uses Raft. Raft is a consensus-based distributed systems protocol. It requires consensus, which typically means you need more than one for, you need 2 out of 3 to get quorum and for changes to go through. So when you build a Incus cluster, you usually start from one system. When you start from one system, that one obviously is the only voter and leader of the cluster because there's just one system. Then you go to 2. When you go to 2, 2 is actually worse than 1 on the Raft model. What I mean by that is if you were to actually expand the Raft cluster to run on both nodes, because you need effectively consensus for anything to go through, on 2 machines, you would need both of them to always agree, which means if you lose either one of them, then the entire thing goes down. And that's why 2 is worse than 1, because if you literally end up with 2 machines where if you lose either of them, the other one goes down as well. The way we actually work around that is we don't extend the cluster to the second machine when it joins. Instead, it becomes a standby/follower role. So it does get a copy of the database, but doesn't get to vote on it. That means if that second system goes down, there's no actual impact on the database whatsoever, because the first machine is still the only voter and gets to keep on going. Now, obviously, if things happen the other way around, where you've got that cluster of 2 and you lose the first machine, then everything goes down. That's kind of the downside there. That said, if you do a clean shutdown on the first machine, it will hand over its role to the other one. So that still works. Anyway, that's why we say we only do clusters starting with 3 machines, because 2 is a massive headache and really doesn't help you. With 3, they all 3 become voters. One of them gets elected leader. Only 2 of them agreeing. The change goes through. And that means you can lose any of the 3 at any point and things remain up and running. Now, if you go past 3, machine number 4 and 5 still cannot participate in the cluster in that they become standby. So they do get a copy of the database. They do get all of the changes, but they don't vote. The reason for that being that now if any of the other 3, so any of the 3 voters go down for any reason, one of the 2 standby can be promoted to a voter almost immediately, which really helps with recovery. So you effectively immediately get back to having 3 voters. The machine that just died gets demoted, and one of the standby gets promoted. If you get past that set of 5, where you've got 3 voters, 2 standbys, then anything after that out of the box is just idle client. So you do not actually participate in Raft. They don't run. They don't get a copy of the database at all. They don't vote. They don't have any of that. They're still known to the cluster as far as Raft is concerned, so that in the case where you lose one of the voters, one of the standbys will get promoted to voter, and then one of those idle machines will get promoted to standby and then get a copy of the database at that point. So that's effectively how that works, which means that kind of the first 5 machines in your cluster end up really participating in it, and anything after that doesn't, which means that's why we can scale without any issue, because it actually doesn't, like adding more machines doesn't impact the database at that level. The scalability concern is more around how much traffic do we actually get to the database, how many background queries and stuff hit the database, and when does that become kind of too much to handle. So that's kind of the scaling limit, and that used to be around 50 machines, but we improved the hell out of the database over the past over the past year or so, I guess, on LXD and Incus. So that easily goes to 100, and we've done, as I said, stress tests on beefier machines going to 200-300 without really seeing any issue. So that's kind of the logic around cluster and the limits as far as the size. Obviously, when I say like the first 5 are special, that's not really true, because those roles do move around. So if you do say a weekly rolling reboot type thing, it's not going to be just the first 3 that remain voters. At that point, some of the voting roles are going to be moved to the standby. Some of the idles will become standbys, and eventually, after enough rolling reboot maintenance or power events, issues, or whatever, you're going to end up with those roles kind of being spread all across the machines within your cluster. But you will remain with, overall, 3 will be voters, 2 will be standbys at any one time, and the rest will be idle. Those numbers can also be configured. The 3 plus 2 model is the default, but if you have reasons to need more, you could go to 5 voters, 4 standbys, or something like that. We found that in general, 3 plus 2 is perfectly fine. That's the best performance you can get out of it, and it still gets you all of the HA behavior that you want. All right, I think that's all for questions at this point. Kind of where we are with the incus-deploy thing. So I like a few weeks ago, I kind of just dumped a couple of commits in there, and that was it. I was hoping to get to do more work yesterday and this morning, but then things happened. I didn't have time to do much of that. So kind of on the Ansible side, what I've got right now is kind of my Ceph deployment stuff, which is here. And the way I do Ceph deployment is maybe a bit different from what some of the others have done. You'll also notice this is not based on Ceph Ansible. Not really because I've got any problem with Ceph Ansible, just because I was used to doing this stuff by hand already with Ceph, and I just dumped it into Ansible at a time. What I've noticed is if you look at Ceph Ansible or some of those other kind of purpose-made playbooks, if you wish, they're good, but they're kind of all standalone. They're not really meant to be integrated with others. And in this case, the goal is to be able to point this at 3, 5, whatever machines you have, and just say, I actually do want Ceph. I do want those disks in Ceph. I do want my Ceph monitor to be on those machines. I do want manager MDS to be running in those containers. And then run Ansible and just have it configured out, but also configure Incus to integrate with Ceph. So make sure it's got the right Ceph.conf, that it's got the right keyring, that it's got all of that kind of stuff all in place. So it can just immediately interact with it. And you don't need to have like completely separate steps for all of that. So that's kind of the idea. What I've done actually yesterday, and I can show you that, is, and I don't know, I'm probably considering myself like as an intermediate-ish person on the Ansible side, but I'm a complete noob on the Terraform side. So I've been actually playing with Ansible a bit yesterday, and I can show you where I got there. So the Terraform side, the idea is that I want to have 2 things. I want to have effectively Terraform files that let me deploy the bare metal machines or the VMs for the Incus cluster and deploy that on just about anything. In this case, for development, I'm actually using Terraform against Incus to create a project, create virtual machines that are then used as the base for the Incus cluster we're deploying. So it's a bit of a weird case, but it works great for development. But the idea is to then use the exact same kind of definitions and concepts to target something like Mars, MetalSoft, or any of the other platforms to deploy bare metal machines, so that you can actually get the machines themselves deployed properly with a base OS and everything. And after that, use Ansible to actually do the deployment of Incus, of Ceph, of Oven, of all of those bits on top of those machines. This will then result into a working Incus cluster, which then allows you to use yet more Terraform, but this time instead of talking to the bare metal provider or equivalent, you instead talk to Incus itself as to the cluster, at which point you can use that to, say, create a project for infrastructure services and then deploy, Grafana, Prometheus, Loki, some of the Ceph services, or some of the Oven services, all that kind of stuff as containers on top of your deployed Incus cluster, and then deploy the actual software in those, again, through Ansible, and configure Incus to actually consume and integrate with those services. So the idea is really to have like a mix of Terraform for doing the machine or container or VM kind of deployment, just configuring the infrastructure, configuring the storage, the network, configuring all of that kind of stuff, creating the instances, and then once the instances exist, those effectively get configured from that point on through Ansible. The idea is to also provide Ansible playbooks for day 2 type operation. So for things like, hey, I need to do a rolling update type thing where I want each of the servers in a cluster to be evacuated, then all of its updates to be applied, then reboot the machine, then restore the workloads. Having playbooks to do those kind of things, because that's what you should be doing, every week or every 2 weeks or whatever your maintenance schedule is, to really maintain your cluster. And probably want to also expand that kind of down the line for how do you do like more complex project creation that not only involve you need to create a project, but you also need to configure OpenFGA to give access to the right people. You need to potentially create entries in something like Keycloak, that kind of stuff. So it's really going to be growing, I hope. And I think a lot of that is going to have to hopefully will come from other contributors. As I said, I'm no expert on Ansible or on Terraform. In the case of Terraform, really not by a long shot. So having others who are quite familiar with the infrastructure as code tooling and who can help really make that repo super easy so that someone who wants to do their first kind of production grade deployment of Incus as a cluster can clone that repo, already have some examples for most of the kind of deployment systems they might be using for their physical machines in their data center or in their home lab. Use that to deploy those base machines and then deploy the cluster on top and then deploy the next layer with like the monitoring stack, authentication stack, all that kind of stuff on top of the cluster, and really be given like a fully functional, everything is integrated, everything is all good to go cluster that's safe to use in a production environment. So that's the goal. I can show you what I was playing with last night, which is Terraform. And again, I'm sorry, I'm sure we can do this significantly better than I have. I actually do want to improve it a tiny bit today, probably as part of this call, to make it like just trying to remove some hard-coded stuff effectively. So this is using the Incus Terraform provider. I'm actually using OpenTofu as the client, but that doesn't really matter. It's still pretty much the same thing. So it just specifies that we're using the Incus provider that we publish. And then I've got a list of instances currently defined here. So I've got cluster 010203. I want to create a new project for that, which is called dev-incus-deploy. So this is used effectively as the testing environment. I think down the line I also would like to have this repo actually have automated tests that can run to validate that the whole thing works, and that's this like initial pass is kind of the first step of that. Then inside of that project, I'm defining a new profile called cluster, which is the project the profile. Oops, this is wrong. It's the profile that's used for the VMs inside of that project. Each VM I'm giving 4 CPUs, 4 gigs of RAM. They've got a root disk, no special size or anything, that's fine. Syntax highlighting, okay, fine. Let me see if I can do VS Code. I'm actually surprised that VI didn't do Terraform syntax highlighting. Anyway, let me just do VS Code. And I think I need to do like a new workspace of something of some kind. Or I can probably just open the file. Yeah, that I go and see, yep. Incus-deploy, Terraform. Well, apparently it's about as good at doing syntax highlight as VI is, at least without adding any extra plugin. So anyway, that's something I should probably look at. I'm surprised there wasn't that there's no that this thing just didn't happen. Anyways, so saying CPU RAM is set. I've got a root disk. I'm using the default size for the root disk. That's fine. So it's gonna pick 10 gigs probably in my case. Currently, single network card just plugged into a normal bridge. Nothing weird there. All right, and then I'm defining 3 disks for each of the VMs. So each of the VM gets 3 disks, 2 disks that are 20 gigs, 1 disk that's 50. The idea here is the 20 gigs are probably gonna go into Ceph, just to have 2 OSDs per machine to kind of play with. And then a 50 gigs disk that will be used for a local storage pool, probably using ZFS for that. I think the other thing that could be interesting to put is to also put a shared disk on LVM to kind of stress test it out. But because I'm mostly focused on Ceph for now, I'm not gonna do it just yet. But that would probably be easy enough to do. I'm actually slightly tempted to do it now that I'm talking about it. Because like so far we've got disk 1, 2, 3. We could do a disk 4 that is not for each instance, but that's actually shared. So let's just do that. That's easy enough. Oops. There. So that chunk, copy pasting that. Let's call it disk 4. No for each. I don't remember if if volumes can have descriptions. I think they can. So let's give them a description. Description. First, Ceph OSD drive. Then that's second Ceph OSD drive. And this one is local storage drive. And then this guy is shared block storage. Okay, so let's give it 50 gigs too. It's within the same project. Its name should just be, what do we call this thing? Shared disk. There. Let's just call it that. It's gonna need a extra config key, which is security.shared equals true. Otherwise, we won't be able to actually put it in. And this one should actually come through the profile. So let me just copy paste one of those device chunks, yeah, and put that in the profile here. Okay, so it's disk 4. It's coming from the default pool, attached over NVMe. The source should be incus-disk4.name, so that way we get the right relations and stuff in place. That should be all right, I think. Okay, so that should be okay. And now that should give us, so if we look at the instance part, so instances, we're going through that list I've got defined at the top. We're using Ubuntu 22.04 virtual machines. It uses the defined profile. I think we probably still want to apply default. The default profile is currently not managed by Terraform, so I just need to call it by its name. And then we've got the 3 disks attached to that. So let's see if I screwed anything up. Okay, seems happy. And I'm just checking, but in theory I shouldn't have that project yet. Yeah, it's all been cleaned. So let's just do it to apply and let's go. I think just playing with Terraform OpenTofu yesterday, I think the kind of the killer feature for me is really the ability to destroy all the mess and just recreate it immediately afterwards. And that's nice. There's been an issue open for a little bit to try and get the ability to do a force delete of a project that would destroy everything inside it. That's in progress. That's not been done yet. And so it's a bit of a pain to actually empty a project so you can delete it. The fact that Terraform does that for you is quite convenient. That said, I did find a few Terraform kind of glitches, bugs and stuff yesterday when I was playing with it. So I'm probably gonna spend some time after this live stream to try and fix some of those rough edges. The other thing with the Terraform support for Incus itself is it's not complete, not by a long shot. It's missing a whole bunch of resources, things like I think network ACLs are not covered, a whole bunch of other things. So there's a bunch of work to be done there. We've got quite a few folks who have been contributing to the provider now, and I'm hoping to have more folks also be able to help us out, because there's quite a bit to do. But yeah, we should be able to do a really amazing job once everything is in there. Anyways, we can see that everything's been deployed. It should be happy if we do, validate, nothing to do, plan is nothing to do, all good. And if we switch project to dev incus-deploy, here we go. We've got our 3 VMs, they've got IPs, they've got everything. If we go look at the first one, let's just do an ls block in here. And yeah, sure enough, we've got 4 NVMe drives, which for some reason are sorted in a bit of a weird order. But anyway, that's fine. And if we go look at those drives by the ID, we can see here that we can find them pretty easily. So that's convenient. That's what we'll be using as the identifier when we deal with Ceph, just so that things don't move around. And we can see, disk 1, 2, 3, 4. So the name of the device in Incus is effectively pushed to the drive inside of the VM. So that's all good. The one thing I wanted to do, and it might be painful to watch for anyone who does Terraform pretty regularly, but I've got a few too many things that are hard-coded in here that I don't extremely love, specifically the name of the default pool. That's something I'd like to see go away. Same thing with the bridge device. So the idea, I think, is to effectively import the default profile from the default project, and then extract the name of the network for the if0 device in there, as well as for the pool, the pool name from there as well. That shouldn't be too bad. I did look specifically at the syntax for that. I think if we look at the documentation for Terraform incus, I think if we look here, that gets us to the docs. Yeah, there we go, documentation. So what we actually want to do here is go incus profile. And what we need to do is doing an import so that we can import the existing thing. So effectively copy paste that. Also need to split that stuff into different files. That's obvious, but for now, I'm not gonna bother. So here we've got resource incus profile. So this would be, what do we call it? Maybe that, to say where it comes from, because the project itself is it's default from the default project specifically. And then we do an import to incus profile default, and we're importing from default project default profile. Okay, so that should be okay. That shouldn't actually do anything in theory. Okay, it does one import. Will perform following actions. Okay, and then it's trying to do bad things because it's trying to actually modify my default profile. Yeah, how do I handle that? Yeah, I don't think that's true. Because that does work to effectively import, but then as soon as it imports it, it's trying to now make it conform to that, which is an empty profile, which wouldn't go and wipe the entire profile. Obviously not quite what I want. Yeah, I'm gonna have to figure that out later. There probably is some kind of way to do this where you import it and then you can access its content somehow. But anyway, because I'm pretty sure if I just remove that, it's gonna not be happy with me. Yeah, that makes sense. Like, it doesn't actually have a definition for it anymore, so that wouldn't work. Okay, fine. Something to look at later, because yeah, it would be nice to not need to have folks go and update this to suit their environment. effectively go and assume that they do have a default profile in a default project, that it has a network and a root device, and that you can just consume, like effectively reuse the pools and the network that they have for this specific project and profile that's being created here. Anyways, something to look at later. Let's look at the Ansible side, since I'm a bit more familiar with that mess. I'm gonna show you probably on the web interface, just because it's gonna be a bit more visual and easier to follow. Is it this one? Yeah. Okay, so what do we have here? In the Ansible part of the repo right now, I've got an Ansible config. The Ansible config pretty much just says I'm using a YAML file for the inventory. That's mostly a preference thing I'm gonna use to dealing with YAML for that. I don't know yet. I might actually switch to effectively switch to a you could switch to an INI file. I don't know if that's, we're gonna have to see kind of how things look at the end of this exercise, see what works best. But currently I'm quite liking YAML for that stuff. So here's an example of the YAML inventory. You can see that we've got some global variables, so that applies to absolutely everything. In this case, it comes with a Ceph file system ID. Probably gonna be removing that. I don't know yet. Like it would make some amount of sense if we would just generate one, store it in a file automatically if it's not specified, but yet allow the user to specify an FSID directly in there to kind of supersede that. Anyways, it then comes with the list of IP addresses for who the monitors are. I'm probably going to be switching that over to using the names of the machines in there, or just the roles. Actually building up the list of monitor IPs from the roles makes more sense, especially since for other reasons I will need to have a kind of what's the internal address, what's the external address for each of the machines in there. So anyways, this is probably going to be going away. Then we've got some other Ceph settings. So in this case, it's the RBD cache. This is particularly useful if you run VMs. Like Ceph is not super good on latency, to say the least. Throughput is not bad. Latency is really quite terrible. And so the only way you can make things pretty decent is by doing a fair amount of caching on the machines to kind of limit the latency whenever the same data is being accessed again, or even acting as a kind of temporary buffer for your writes. So that's what I define here. Well, effectively, that means that each VM gets to get up to 2 gigs of cache, which is pretty generous, but some people will probably go with lower values. And then you've got a target of 1.5 gigs. So that means that we're quite happy with 1.5 gigs being used. The maximum is 1.7 or 1.8 gigs effectively, meaning that at this point it will very actively flush the cache back to Ceph. In general, it will do it earlier to try and make that 1.5. But that's kind of the idea, is that we want to have a bit of a buffer, like a 250 megs buffer between the target and the max, where things can kind of go up and down on their own, but as soon as the max is reached, then those writes really need to start getting flushed. Max is below the full limit, so that there's still a bit of extra space for more writes to come in as things get flushed. So that's kind of the idea there. Then the way that actually works is we've got servers defined here. So that's the machines you have, in this case, server 01, 02, 03, 04, and 05. Each server has a list of roles for Ceph. They're gonna similarly have a list of roles for Oven as well. And currently the way we have done it is the first 3 are acting as both OSDs and monitors. And then the remaining 2, they just inherit that variable here, which makes them just OSDs. As a reminder, on the Ceph side, OSDs are disks. So just like it's the disk daemon saying I want to expose those specific disks. Then the monitors is the main kind of database control plane distributed systems part. So that's also, well, Ceph doesn't use Raft, it uses Paxos, which is very, very similar to Raft in concept. And that kind of works the same way, where you need to have those 3 servers clustered. You need 2 of them to kind of agree for anything to go through. And they effectively control who can access what, and give them then the credentials and the pointers to the OSDs to then perform the actual disk access. So in a cluster, you need 3 of those. Currently, the way I'm thinking of doing things, and people can obviously adapt that to whatever they prefer, is to do OSDs bare metal, because you kind of need to anyway. So those daemons run directly on the bare metal machine. Same thing for the monitors. So monitors would run on bare metal as well. That's not strictly required. You could run the monitors inside of containers, but then you need to be careful, because you end up with a potential chicken and egg issue, right? You need to make sure that those are on local storage and never depends to anything that's on shared storage, so that those containers are guaranteed to be able to come online. And then about a minute later, Incus will detect that the Ceph cluster is fully available and then start everything else. It can be done, and it does work, but it's something that people need to be quite careful of if they're doing that. So that's why it's usually easier to be like, okay, well, you know what? Let's not even try doing this. Let's just run the monitor on bare metal as well and avoid that whole kind of worms. The other services that Ceph has, which include MDS, so that's the Ceph file system kind of layer, Ceph Manager, which is used for background tasks and kind of day-to-day operation type things, Ceph Rados Gateway, which is used to provide an S3 API, or even the Ceph RBD mirroring logic, which is used to replicate blocks across multiple Ceph clusters. All that stuff, there's no reason not to run them in containers. So those you probably wouldn't run on bare metal. But monitor and OSDs, you probably would. On the oven side, it's going to be kind of similar. Each of the machine is going to be running, if oven is used, it's going to be running Open vSwitch, as well as the oven controller on all of the machines. But then the oven databases and chassis services, those will only be running, well, central services, no mind, oven central. Those will be running also just on 3 machines in most cases. Same thing with, like, you don't really want a chicken and egg affecting your network either, so probably going to be running on bare metal initially. Careful users using local network and all that kind of stuff could get them up and running in containers or in VMs. So that's kind of the idea for Ceph and Oven. Now that we've got shared storage, I'm also going to be trying to put some of that logic in place. So currently the state of the Git repo is that it's got a decent dump of my playbooks and template files and that stuff for Ceph. So in theory, we should be able to configure things to point to those 3 VMs that just deployed to Terraform, and then try and deploy a Ceph cluster across that. And Terraform makes it super easy to throw everything away and recreate it, so that makes it easy to try and debug. So let's try and do that. Going back here to a terminal. All right. So first thing to do, copy that. Actually, the first thing to do is that I don't even have Ansible installed on my machine, so I should probably fix that. Yeah, that seems fine. I don't have it installed because usually I actually use a container that's got Ansible installed. But in this case, since I already have OpenTofu installed locally anyways, I might as well also install Ansible. And you actually notice, like, I'm installing an older Ansible, 7.3. We saw earlier that for the Incus integration, you can need 8.4. That's not going to be an issue because there's a nice trick that was also in that Ansible config earlier that you may or may not have seen, which is connection plugins points to plugin/connection. And I conveniently have no copy, but I'm going to fix that, of the So I can put a copy of the Incus connection plugin directly in there. Let me figure out, I've got a copy of the Ansible source tree somewhere. Yeah, there we go. So let me find the Incus plugin. There we go. And I'm just gonna copy that into plugins connection. And now I've got access to that plugin. So that's all good. Host.yaml. So now is when we need to actually configure this stuff to be able to interact with the servers. I said the servers in my case are virtual machines and they don't have those names. So this is actually cluster 01, 02, 03, cluster 02, cluster 3, cluster 4 and 5. Okay. Then I'm also gonna have to change the path for the disks. So if we go look inside of one of them, by ID, okay. The good thing is that this is going to be identical since all the VMs are the same. So I just need to go here and change the name, and that is the by ID name. So 1, 2 are Ceph, 3 is local storage. Okay, so we just do this one, and then that one, and we replicate that on all of them. Obviously, if you're running on physical hardware, you're going to want a bit more. It's going to be a bit different since you're going to have actual device names. But in my case, just a VM, so whatever. Let's just use it that way. Okay, so that's good. The next step is the list of monitors. Again, I want to do this differently down the line because it should just be able to pull the IP addresses of the VMs. But for now, let's just do it this way. I actually wonder if that's going to work. The reason why I'm wondering is my own infrastructure is IPv6 only. So I've never actually used that playbook with IPv4. So that's kind of the other way around from what most people do, where like they get into trouble when they try to do IPv6 because IP addresses are different and everything blows up. But we might actually see an issue with that. Because I might be making assumptions around IPv6 addresses. Anyway, I'm going to use IPv4 on purpose because if there are the wrong assumptions inside of the playbooks around IP format, I might as well know it now and fix it now. Again, this stuff is going to have to go away. I think the way it's going to actually be done down the line is that we're going to want like a something like IP_public and IP_private. I would probably, so the point being that you might have a separate management network separate from the public network. The public network is what Incus and stuff should listen on, but then private is what you want to have Ceph and others listen on. So the way I would probably handle that is we'll have public default to the private address and then have this one actually use the correct IP address. Also, we currently only have 3 servers. I did have 4 in that playbook, so we can just go and just use Terraform to deploy another 2. That shouldn't be a big deal. So just go here and do cluster 4, cluster 5. Okay, and go ahead. So just creating the disks and then deploying the 2 extra VMs so that things like all that stuff lines up. Actually, in my case, let's make our life slightly easier and actually set that we don't have a distinction between public and private. So we're just gonna have things that way. I believe I just heard a delivery truck pull in front of my driveway, so I'm probably gonna have to step away for a minute or so. I've got some networking gear being delivered, but just check what's going on. because I heard the truck, but I didn't hear a doorbell, which is slightly odd. Let me check what's going on. Yeah, there's definitely a delivery truck here, so I'll be right back. Sorry about that. I'm back. All right, sorry about that. Just bringing the cat again, in case anyone wanted to see him. There we go. All right, back to sleeping. Okay, so that should be it for the interruptions for today. Now, we've got those extra 2 deployed, and I was just putting IP addresses everywhere. So, 02 is 182. 03 is 153. And then we've got those extra 2, 83 and 71. Okay, cool. So that's fine. Next, we've got to actually set a connection plugin in place. I'm gonna cheat tiny bit and just in another terminal go look up at my production Ansible setup for what are the magic config keys again. I think it's Ansible connection I need, but let's go figure it out. There we go. Okay. So what I need for those servers is to set how to access them. So Ansible connection is incus, so that's the plugin that we want to use. Ansible incus remote, that's just in case. Like in my case, it's going to be local, so it's fine. Need to tell Ansible to actually running everything as root, that there's no need to run sudo. And there's also Ansible incus project, and this is what did we call it? It's dev Ansible deploy, dev incus deploy. Okay. All right. So I now have effectively those servers fully deployed, well, fully configured with their config, and then I separately need to actually tie them to groups to specify that they need the Ceph playbook to be applied. The reason for that is if we look at the Ceph playbook, it shows hosts only run on anything that's in the Ceph group. So this part was checking. So this is servers, okay. And we've got the hosts defined here, containers. I'm just wondering if I need to do like an extra level of indentation in this stuff. Just check how I did it usually, because I need to just assign those groups and trying to keep a tree that kind of makes sense. In my Ansible YAML here. Okay, so children, this is location. Okay. Just quickly looking at my production stuff off screen to get an idea for how I did it in the past. much longer than I remembered. Okay, that's still the site-specific stuff. Okay, and those are the actual groups. Yeah, so right now we've got servers and containers, but I think we actually want to add an extra level effectively here. So instead of, so we need to do children. I'm gonna have to re-indent everything, which is slightly frustrating, but so we've got servers, and under servers now we're gonna have the I forgot another children level thing here. Okay, right. Did I get this right? Hopefully. Actually, I should be able to check with Ansible inventory. Is it tree? No, it's not tree. It's something out of graph. Okay, it's mad. Failed to pass with YAML. Okay, it makes sense. It's a bit mad because of the indent, probably. So children servers, children. Oops. This feels wrong. It's probably just. Oh. Did I get that right? Let me check. So this is the top level. This is then that. Then we've got the name of the group, and then yeah, we've got hosts and vars. Okay, so that should be fine. I mean, it's gonna be mad anyways because of the indent at this point, but let's just get rid of the rest. Okay, so it shows servers and hosts. Okay, that's good. This one has just want to make sure that this still lines up. No. Failed to pass. Unable to read. And the part of the thing that's making it confusing to me is this one, because it should not be host, actually, the name of a children thing. Okay, so we see servers, we see food. Okay, so that's fine. Now if I go again, sorry, looking at stuff kind of off screen here. So vars is fine, and then yeah, so the actual syntax here should be okay, but it needs to be aligned here. This is hosts, and then we've got cluster 01 here. That in theory should be okay, but I think okay, yeah, we're good. Cluster 01, cluster 02, and the rest. Okay, fine. So let's just go back here. Cluster 01, cluster 02, cluster 03, 4, 5. That's fine. Those are probably messed up, so let's just remove that for now. Yay, okay, that makes sense. Okay. Yeah, part of the confusion was because of me actually calling the group host, which then also makes it look like it is a host list instead of Ansible, but now it's happy. That's good. Okay. Then we've got the container stuff. This is going to be misindented probably because it should be, yeah, it should be at that level. So I think we just need a full 4-space indent fix. Anyway, this section is not really relevant right now because we don't actually have any of those. But that's fine. So anyway, I'm just gonna comment this whole chunk up. Come on. Okay, so those are commented out, and then we should be able to finally get what I needed, which was the actual groups to say what services need to be applied to what thing. Oh, and okay, so that's another part of the confusion, I think, is that this indent is wrong. So let's just go all the way through and remove that level. Is it still happy? Yeah. Okay. So servers here, those are the actual machines, but then we need a separate set. And I need to look at INI. Maybe the INI stuff actually makes that easier these days. We need something called services. Don't think the indent is right. Come on. Sorry for going back and forth like mad. This is probably not super easy to follow. Okay, so services, and then we've got suspect children here. No, services, children, yeah, and then we've got the groups. Okay, cool. So that means that here now we can finally have what I need, which is Ceph. So that defines the Ceph group. And the Ceph group then has a bunch of hosts inside of it, which is going to be cluster 01, 2, 3, 4, 5. Yay! Okay, so that's fine. So now we've got that Ceph. The Ceph playbook is configured to run on any machine that's in the Ceph group, and the hosts have their config. The two gets merged together, and that should give us kind of what we want. And so let's try. Actually, just run in diff mode for now, see what happens. It's failing pretty early on. That's usually because actually no, its connection plugin has an improperly configured remote target, forcing inventory host name. What was I doing around that? That rings a bell. How was that? Like, it effectively needs to figure out what to do for the like what host name to actually pick. And I believe I did something for that on my deployment, but that's not working here. Why isn't it working? I'm checking if there's if I had a workaround for that somewhere. Not seeing that so far. Does that come directly from the plugin? Because if it doesn't, I can just go check what's going on exactly. No, it's not. That would be way too easy. Let me look for all of the Ansible stuff. Ansible, also that's private key, user, become. Yeah, I don't really have anything weird around that. I guess the main difference is that on my side, do I have FQDNs for everything? Yeah, I do. Okay, let's see if that does any change. So on my side, I don't have just pure host name like that. I tend to actually have like dot project name dot something. So in this case, let's do it with the project name, see if that helps somehow. Incus-deploy. Not sure why it would exactly, because the the base of the conf, like the actual relevant config is all there. But who knows? All right, fine. Let's look at the graph. That looks reasonable. And it's still blowing up. Okay, let's try not in diff mode just to see if that makes any difference. It does not. Well, I mean, it helps a bit. Like you do need Debian is Ceph base. Okay. So there's some dependencies for that playbook. Specifically, it needs to have access to the tools needed to generate the monitor map and OSD map for Ceph. So that's the Ceph base package you need to have installed. I'm not quite sure why it's pulling a whole bunch of stuff around NVMe, HD palm, and all that kind of stuff. That's a bit weird. But anyways, it feels like the monmap tool should probably be in a different package, but that's a distro thing. Okay. So now I've got monmap tool. That should get us past that, and now we're failing. Monmap tool invalid IP port. What did it get past? I wonder if we get our first IPv6 issue. Item. Okay, well, that's not a very specific error, is it? Ceph monmap, okay. That's the path to there. Okay, what's the issue exactly? I'm pretty confused as to what the error even means. Okay, time to see what this stuff actually does. I'm not always the most fond of debugging Ansible failures like so let's just do monmap. I'm so confused. Is it running monmap tool? Because it didn't call the binary if it did. No, okay, it cleared that error and went straight on to the next one. Oh, that's lovely. Did it call the incus command out? Okay. Yeah, so we see it tries to use inventory hostname instead of what it's supposed to. So I'm just really confused that I don't have that problem in the slightest on my home stuff. Like, what the hell? Like, I'm sure it's something extremely stupid, and once I actually figure it out, that's gonna be really annoying, but why? Like I said, like I don't think any of this stuff should be needed in the first place, so clearly that didn't happen, so there's no need to keep that around. Like the inventory name is right there, like it's cluster 010203. That's what we see in the graph output, so I'm not sure what it's complaining about. Actually, there was maybe a hint of, no, okay, it just shows the correct name. Ansible connection plugin is incus, it's local remote. There's really nothing weird. Because the one thing I'm wondering now is my plugin just busted? So let me actually check the one I'm using in production. Yeah, thanks for watching, Andrew. Sorry for things being a bit more rough than I expected here. It's probably something really dumb. Is it just that the plugin is wrong? No, I'm using the exact same plugin. Okay, so that's not the issue. Would have been a nice issue to have. It's just a plugin being wrong. because it shows default inventory hostname fine as the identifier. I'm so confused. Like, this is literally the same thing I'm running every day in production. I don't have this issue at all. Rechecking the Ansible stuff just for the hell of it. Yeah, hosts.yaml. Yeah, I mean, this is literally copy pasted from my own production stuff, and it doesn't have any of that problem. Okay. I can probably override inventory hostname or something to make it work. That would probably be fine, but why? And again, just scrolling through my stuff at home to see what may be going on here. So I need to look at something that deploys on containers. Okay, so that's instances. Okay. All right. Got a lot of variables I need to scroll through. Come on. Yeah, there's absolutely nothing around inventory or any overrides or anything of any of that stuff in there, and it just works. What version am I running over there? That's the other question, maybe. Okay, the version of Ansible is quite widely different, so that could be the issue. Maybe? I'm not sure it would be. Anyway, let's see if we can just work around this mess. So what's the exact error I'm getting? Actually, hold on. I'm pretty sure this stuff got fixed. Like the error kind of rings a bell now. Let me pull an update on this guy. No, set my fork instead of the upstream. Yeah, it's remote. So just give it remote update. Okay. I'm gonna rebase my branch on upstream/main. Okay. Never mind the rebase. I'm just gonna go for a straight up reset, given that all my stuff was merged upstream. There we go. Okay. I suspect this is gonna fix it, and it's gonna be quite annoying. Incus-deploy. Okay. So if we do Ansible. Okay, so that's our plugin. Not copy of the plugin anyway. Ah, come on. Okay, the hash compared to what's currently in the repo, because now I'm kind of remembering that someone sent a fix for something out. Yep, sure enough, the actual content is different now. So let's see if everything was actually fine. It was just a updated version of the plugin. Well, that's doing something. Yep. Okay, well, that was the issue. I'm guessing I don't have that problem in production despite running the older plugin because I'm running an old version of Ansible and it's kind of just doing things for me. But yeah, apparently if you run the current version of the plugin, things work a lot better. So that's cool. Let's see where that fails because it's probably gonna fail at some point. I did dump all of those bits into the repo a while back, but I never actually tested anything. So there's a very good chance things are actually going to blow up once it gets to Ceph config. Anyway, there was a questions around unrelated. Any chance you know what DNS stub listener is for in systemd resolve D? I keep turning it off. Default is on. Yeah, so the stub listener, let me just get into a random container somewhere. Actually, I can use one of the VMs. So if we go inside one of the VMs here. Okay, so if you look at your resolve.conf, this actually says this is using the stub resolver. And that points to name server 127.0.0.53, which then goes to resolved. That's because there are two different ways to access resolved. One way is kind of the legacy way, which is to talk the DNS protocol over localhost, and that gets to resolved. The other way is to go through the NSS stack, which we can see here. Usually, I guess, I'm actually surprised it's not listed in the stack. But effectively, if you do get an host, yeah, so if you do that, this should not actually cause a DNS query against the stub resolver. That should go straight internally through a shared library to resolve and then return the result for you. So that's the idea. The stub resolver is kind of a legacy compatibility layer that's used for all applications that don't go through libNSS. So that's the general idea. That means that resolved itself. So if we look at resolved okay. So we can see that systemd resolved listens on localhost on port 53, and that's the stub resolver. If you turn it off in a restart resolved, I expect that the result is that etc resolve.conf will now show you the upstream DNS config, so effectively the equivalent to what's in this one, instead of the stub stuff, which would be that one. And then the resolver goes away. This is usually fine because most of the time all that resolved does is just send queries to your upstream DNS servers and does some amount of local caching and some validation. That's it. It's going to be a problem if you often use VPNs, because one nice thing that resolved can do is doing split DNS, where it knows that some specific domains and networks should go over your VPN when the rest shouldn't. And so it can actually do that dispatching role. And if you turn it off, so if you turn off the stub and then you're using software that doesn't use NSS, and that completely bypasses resolved, then that's not going to know that for some domains it needs to go over your VPN's DNS server, and for the rest it should go through the normal network's DNS server. So anyway, that's that. Now let's see what's going on. Like, things blew up to hell. Kind of expected, but specifically unsupported parameter. Okay. So I think the short version is resolve.conf, ceph.conf is not good. Maybe. Failed. So it's LVM Ceph volume blowing up. Trying to access the disk, non-zero. This is a bit of a mess to read, but it was unable to read configuration file quite repeatedly. So I'm guessing that ceph.conf is not good. Oh yeah, that's definitely not good. That's a behavior I really hate. They will, like, if you can't template something, just dump the template in instead. That's really frustrating for that kind of stuff. And again, I'm sure there's a much better way to debug this stuff than the way I usually do it, but oh well. So what is that template accessing and what might be missing? So if we go look at this, ceph.conf, it's templated here. So it's got access to all of that mess. Ceph FSID, we know is set properly, so that's not the issue. Then Ceph monitors. Okay, so task Ceph monitors. And on those, it looks for the IP attribute and the name attribute. So I think that's the issue. I don't think that's how that's been specified in here, from what I recall. Yeah, it's not. Okay. All right, so let's fix that. Again, interpreting some of those errors is quite annoying. It's good when we can figure it out like that, but anyways, and as I said, that Ceph monitors thing, I wanted to go away, so that should take care of that problem down the line. Let's see. So hopefully it was the only issue with the Ceph.conf, that will regenerate Ceph.conf and then try to add the OSDs again. Yeah, that's better. It actually has IP addresses. It is using the square bracket syntax around IPv4 addresses, which may or may not work. It kind of depends on software. Some of them don't care, some really do. So that's going to be interesting to see. And we're seeing more issues because of using a more recent version of Ansible here than I usually do. So that's not good. And that's failed the bootstrap of the Ceph monitor. So that's going to cause issues for sure. But we're going to let things go and fail a bit later, I guess. Also, public network, private network being left set to empty. That's not good. Like if they don't exist, those keys should just not be set. So while we wait for that thing to blow up again, I'm just gonna go and tweak the template a bit here. Okay, public, private here. It's just end up on those templates. The issue with doing that kind of templating is that it's gonna completely screw up all of the line breaks and stuff again. I think we kind of want to do something like that, which would clear any space leading to it. Not sure if we need to do anything afterwards, because that's gonna cause a line break, like an undesired line break. Maybe just do that way. That should be clean enough, hopefully. I mean, that's mostly my OCD at that point of like me not wanting to see kind of weird line breaks and stuff more than anything else. The other error is, let's look, it's complaining specifically around legacy command, but I don't think I'm using that. So anyway, what does Cephmon do for the bootstrap? Okay, it's using shell cmd. Okay, so apparently that's legacy now. Support parameters include, okay. So what's it, which one is it complaining about? One. Okay, so it's complaining about this guy specifically, the warn. Not sure what it used to be doing. Oops, thanks for pointing out. Indeed, that would have been a slightly annoying one to see down the line. We'll probably have seen it in a diff later, but thank you. Okay, fix that. Let's see if there's any other warn stuff in there. There are, okay. I'm gonna remove those for now and see what kind of complaining it does. Since apparently it didn't run anything because of it. And right now we're bootstrap Ceph OSD and nothing's going on. So what's Ansible actually doing right now? Assuming it's doing anything. Okay, it's doing stuff on cluster 4 and 5. Okay, so that's why I didn't see anything on cluster 1. Okay, this is installing stuff. Oh, but that's never gonna work. Okay, so that is gonna hang indefinitely. And I think that's probably gonna be our last try of the day, because otherwise this live stream is gonna last way too long. But I'm gonna blow away the entire thing through OpenTofu. So it's just destroying the entire enter a deployment, and then we'll just recreate it, and then do a new test run of Ansible on top of that. That's the nice thing of having OpenTofu there. Like usually when I would do this by hand, that would take me 5 minutes to reset. Now it takes me, I don't know, a minute, 2 commands, something like that. So that's good. And yeah, hopefully, I mean, this time around, we should get a valid ceph.conf, so no public private type stuff in there. Hopefully the warning stuff that it was complaining about will be gone. And we'll be able to get a working Ceph deployment. I'm just checking because it does generate some metadata, as we can see here. That's data Ceph stuff. So I'm just gonna wipe all that stuff so that we've got a clean slate there, and then run Ansible again. Okay, so it's generated the local files, and now it's going with putting the repos and everything in place. And let's see how far we get this time around. And yeah, thanks for looking up the Ansible collection stuff. Yeah, I do remember that pull request to fix the inventory hostname thing. I did actually review and approve it, I believe. And yeah, that's why I was like, this is weird, because like technically like my production server is running the old version of the plugin that doesn't have the fix, but the older Ansible didn't care. The newer Ansible does care and therefore needs the fix. So that's why I was getting really confused about like this stuff should work, but it's just because of the Ansible version being widely different. My production Ansible server is still running on Ubuntu 20.04, so that's Ansible 2 point something. It's really old. Doesn't really matter for the stuff I'm doing. I do have the incus plugin put on it, so it works perfectly fine. But yeah, that was why I didn't see it on. Okay, so now we're getting all the packages themselves installed. I don't think it's generated except.conf yet. Let's see. Do we have a... Nope, there's no ceph.conf yet. So it's just installing packages at this point. I don't remember what I'm doing. I think I'm probably doing the upstream Ceph repos so that we've got control on the exact Ceph version that's being installed, kind of regardless of the distro. And okay, that blew up again. Innermost needs to be closed is if, okay. Right, so that means I screwed up writing the template, basically. At least it blew up, which is good, because pushing something invalid is far worse than blowing up. And it's actually what needs like a full rerun. Okay, is it endif? Is it... I'm so confused by the 50 different type of templating languages I'm using these days. It's quite possible that the Ansible one requires endif. It's done. Yeah, it uses endif. Okay, I just did a quick grep on my server, some other stuff. So that's the issue. I'm not sure about the dash syntax. That's something we don't use in the oven, in the LexD side, on the incus go side, effectively, where you use that syntax to say that you want to clear line breaks from before or after. I don't know that this is some, like, I'm not seeing that being used in any of my other templates. So let's not for now, and I'm gonna deal with my OCD of aligning things properly later on, because line breaks don't hurt, they just don't look good. That's an issue of the Go template language, at least, where all of the template markup itself still counts as lines. So if you're not careful with telling it like clean lines before and after, you end up with like kind of an arbitrary number of line breaks all across your file, which just looks like crap. Anyway, let's see what that did. Okay, so no such problem with the templating language inside of Ansible. It did generate something that's perfectly nice and clean, so absolutely no reason to do anything different. We can see IP addresses and stuff look plausible. Ceph monitor has been started. Let's see if it actually is running. again, like this, using the square bracket syntax with IPv4 it's valid for some tools, but not for some others, and we might be getting in trouble for that one. Let's see. Unable to bind to. Okay. Did I? Yeah. Okay. So that one is totally on me, which is actually a bit of an issue. But anyways, I need to actually integrate Terraform and Ansible properly for this stuff. Like the problem here is that I use Terraform to blow everything away, which is cool, except that this calls different IP addresses, and so everything it doesn't line up properly. So I'm just gonna blow it away, recreate it one last time, update the IP addresses, and do a last run, and we'll see if that goes anywhere. If it doesn't, then that's gonna be the end of this live stream, because we'll be close to the 2 hours mark at that point, and I think everyone's gonna be tired and want to go do something else. Let's see. So I'm gonna need to update that as soon as I've got the new IP addresses. All of the IPs are gonna be wrong. I can do another reset on that one, so let's just wipe. Yeah, okay, that's clean. That's the new IP addresses, and let's go update everything. So 235.188, 42. Okay, let's go down here. So 1x again, 235.188, 42, 187, and the last one is 87. There we go. Okay, and let's run this thing again. So this time we should actually get at least a working set of monitors. Yeah, exactly. Jared is saying like he uses a Terraform local to actually create an inventory file, and that's exactly what we want out of this. Like Terraform should spit out the list of IP addresses and all that stuff for Ansible to then consume. Like currently, the two are very distinct in that repo, and that's going to be something that needs to be fixed, so that it's really like Terraform does the bare metal deployment. As soon as it does, we get the inventory out of it, and then Ansible consumes that inventory and goes and deploys the actual services on top of it. And then once the whole thing is actually done, then you get the second stage of, okay, well, now Ansible has fully deployed the cluster. Ansible can get the credentials to access the cluster, which we can then dump into Terraform. So Terraform can then create objects on top of the cluster, get us another inventory for those projects that we'll have created, and then use Ansible again on top of it. So it's kind of like a back and forth between Terraform and Ansible, where you do the first stage is kind of doing the bare metal stuff, and the second stage is then doing stuff on top of the cluster. I think it's going to be really neat once that all works properly. We're still just reasonably far away from that. For now, I'm trying to make sure that that the deployment for Ceph works, that the deployment for Oven works, that the deployment for Incus itself works when driven manually. Because that unblocks a bunch of people today, which is really good. And then just kind of go and tie things up to make it tidier and easier for folks to use. So, okay, so it says that that it's done deploying the monitors, and this time we see the OSDs going through. So that's a good sign. That means we probably have an actual cluster. Yep. Okay, so we do have a cluster running. It shows Messenger 2 is not enabled yet. I believe I've got a step that does that. And okay, it's completed, and now Messenger 2 is gone. It shows no active manager. That's fine. It's because the managers are meant to be deployed in containers in this current setup. They're just not there yet. So Ceph is up and running. We do have all of the OSDs up and running across that cluster, and yay. So that's the Ceph side effectively functional. The thing I'm going to want to do is just rerun it to make sure that that nothing blows up if you run it, and that it shows everything as being good. Like it shouldn't report any changes if the playbook actually works as it's supposed to. And that's the whole point of this stuff, that all of it should be things you can actually rerun to make sure that there's no deviation in your config, nothing that needs to be fixed. So, okay, yep, all good. All right, yay. So actually did get the Ceph stuff to behave the way I want. So that's good. I'm probably gonna be looking at actually pushing the oven stuff next in there now that Ceph is actually behaving. I'm probably gonna actually be including the plugin directly in the repo. Currently there's like a placeholder and probably an ignore file actually for those plugins. But I think it makes sense to include the connection plugin, also tweak the gate ignore and stuff for the Ceph bits. So I'll be doing that, I'll be pushing that probably in the next few minutes, and then go and actually do the same thing for oven. I've already done some amount of the oven work for a customer, so I've got already a customer that I'm deploying through a dedicated Ansible container with just my oven bits in there. So that's already been mostly extracted, which means I should be able to add them back in there reasonably easily, and then do a test deploy to make sure that this works. The main issue I've got with oven right now is that my deployment tooling for oven doesn't use TLS at all. It just uses plain text database accesses, which is not good. And I don't want to actually publish that until I've got TLS working. So I'm probably gonna have to do that step next to get oven with TLS and all that stuff in place, and then push that. And once we've got Ceph and oven, then the next step is gonna be to do to actually do the incus part itself, because we need to then install incus. That's easy, we already have playbooks for, but then also handle the clustering. So knowing what are all the servers that are part of the same cluster, and then getting them all installed, pick the first one, do the cluster bootstrap on it, join the other machines in there, and then try and add the storage pools and that kind of stuff on top of it. So that's the part that's gonna get pretty hairy, pretty tricky, but that's gonna be pretty good once it works. I see a question around what's kind of the most difficult between Ceph and oven. And I don't know, they're both kind of different beasts. Oven, in principle, is much simpler. It's got less moving parts. Just got like effectively a database, the daemon itself, which is Open vSwitch, and then a relay that goes between the database and that, and the Open vSwitch to apply changes. That's pretty straightforward. Doing authentication is not too bad. It's pretty simple. The problem with oven is their documentation, which is non-existent. That's the biggest issue. So by now I'm familiar enough that I know kind of what to do, how to do it, and how to automate all that stuff. So I can do oven pretty easily. But for someone coming at it new, that's a massive headache, because there's effectively no documentation, and the documentation that does exist tends to be very specific to either OpenStack or Kubernetes. If you want to just deploy oven mostly as a standalone solution to then you consume it with something like incus, that's just a massive issue right now. Ceph is kind of weird in that it's got a good documentation, but the documentation on manually deploying it is mostly gone outdated or just not really recommended. They're pushing very hard for Ceph ADM, which uses Docker to run all of the Ceph services. The problem with that is Docker is known for, like, when run on the same machine as incus, to like have very negative interaction on the networking side especially. So I wouldn't recommend doing that, which is why I've got this this playbook, which is kind of the bare minimum of install the Ceph packages, do all of the crypto bits, so generate the keyrings, exchange the keyrings, put all of stuff in place, and just get it up and running. So that was the stuff I've got here is based on the manual Ceph instructions. But with enough automation that now it's very easy to consume, you actually get something as fast, if not even faster, than Ceph ADM to get things up and running. The main kind of benefit of Ceph ADM, I think, is going to be on the day 2 operation, where it's easier to upgrade. Like, it's pretty good at knowing the version of all the different daemons and doing the updates in the right order for you. The same will be possible with Ansible. We're just going to need to have some playbooks for that, because with Ceph, you need to effectively change your package repository config first, apply, get the updated package lists, and then you need to update your OSDs first, get all of those restarted. Once that's done, then you can update your, I think it's usually monitors as the next stage, and then you do MGR and MDS afterwards. You need to do upgrades in the right order, and you need to make sure you don't, I think you can skip one Ceph release, but not two. Otherwise, you end up with like incompatible protocols and that kind of stuff. So there's some difficulty around that. The fact that for this playbook, I'm using the Ceph upstream repositories, I believe. Let me check. Yeah. So this is putting in place the upstream Ceph repos, unless you specifically ask to have the distro packages. And the benefit there is you're effectively pulling the specific Ceph release you want. So currently it's configured to pull Reef, which I think is still the current stable. So you have control on the release, and you can update your Ceph release independently from your OS, which then makes it possible to never skip, but effectively go from one release to the next, not even have any gaps, and avoid all of those kind of upgrade issues. I've not had any problem with either of them. Like in production, I've been running both Oven and Ceph for, I don't know, 2 or 3 years or something like that now. And I've been doing major Ceph release upgrades and Oven upgrades without issues. But yeah, you do need to kind of read the release notes and that kind of stuff. So being able to automate more of it so that you don't need to be like familiar with the specific like sequence you need to go through to make everything work, that'd be nice. All right, well, we've been at this for just shy of 2 hours. So I think that's long enough for this live stream. Definitely not like, this is a bit of kind of way outside my comfort zone as far as stuff to do. Like I do use Ansible pretty regularly, but just as a user, I'm not an expert of it. I'm definitely not an expert on Terraform. But we do need a better way of deploying incus. I've done it many times by hand, so I kind of know what I want to see done in what order and how. So I'm trying to automate that, and then I'm gonna be depending quite a bit on other folks to go and clean things up. Like that's the nice thing of having this repo be public on GitHub. Like once we do get a few more pieces, it's going to be moved into the LXC organization right alongside the incus repo, and then people there can go and help out getting support for other distros. Like test it on Debian, see what works, what doesn't, add the few tweaks you need for it to work properly, and then we've got another distro supported on there. Help clean up my Terraform mess and turn it into something nice. That kind of stuff. That's going to be very valuable, and I'm hoping we can have, just like we've got a decent community of people contributing to Incus proper, who are Go developers who kind of know how to do that kind of stuff. We have a pretty large community of DevOps type people using Incus who are expert at Ansible or Terraform, and who should be able to help us out with that deployment tooling to try and put everyone's best practices into just one repo that everyone can base their stuff on. So that's really the goal there. Hope this mostly rambling kind of bumpy live stream was entertaining, if not necessarily useful. And I'll see you in the next one. I'm not sure I'm going to be able to do one next week because I'm going to be traveling. I might try and do something Tuesday, but yeah, best case, I might be able to do a short live stream Tuesday. Otherwise, I might have to skip the entire week and then be back probably Thursday the week after. All right. Again, thanks a lot. If you've got any questions about this, feel free to go down below. If you want to look at the repo, maybe already like send some pull requests or comments or anything, it does exist, but it's currently under my private account. So it's under STGraber on GitHub, and then it's called incus-deploy. Once Ceph works, once Oven works, I will probably be relocating it. So just renaming it to LXC/incus-deploy, and gonna take it from there. So again, thanks a lot for watching. If you've got any questions, leave them down below. Please look at the repos and follow that. And I'll see you in the next one. Bye.